So this video is going to focus on some initial notes on bonding and also how do we make ionic bonds. So this is going into our bonding unit. So realize that chemical bonds involve electrons. And for this particular unit, we are going to talk about three different kinds of bonds: ionic bonds, metallic bonds, and covalent. Now, we've talked a little bit about metallic before, and we've drawn some, or we've written some ionic formulas. So the one we're going to spend the most time on is going to be covalent bonds. So valence electrons, as we've discussed before, are electrons in the highest energy level, and they determine most of the chemical properties of an element. And we've also discussed the octet rule, which is the atoms tend to make the configurations of the noble gases. We are going to skip electron configuration for this discussion, but we get that magic 8. It's all about 8 electrons in that outermost shell. So we're first going to talk about ionic bonds and how do they form. So I'm going to use the example of sodium and chloride. Exactly how do they make an ionic bond? So remember, cations are metals, and these are things that lose electrons, while anions are nonmetals, and they tend to gain electrons, again, depending upon where they are located on the periodic table. So remember, sodium is in the first column of the periodic table. So sodium is right below lithium, and so it's in energy level 3. So I'm going to write down energy level 3. And we also know that sodium is in the first column, so it has 1 valence electron. So I'm going to write 1 valence electron. So I'm going to use VE as valence electrons. So that means in the outermost circle, and again, I'm not going to draw the circle of the Bohr model, I have 1 valence electron. So if we think of it like our paper clips like we used before, we have 1 valence electron in order to make the outermost energy level have an energy level or have 8 electrons. While chlorine, okay, is over here on the right-hand side of the periodic table. It's underneath fluorine, okay, and we notice that it has 7 valence electrons, but chlorine is also in energy level 3. So I'm going to write down energy level 3. It has 7 valence electrons. So I'm going to say, I'm going to line up 7 electrons. So again, what we're trying to do is get to the magic 8, okay? So if it has 7 valence electrons in its outermost shell, it's going to want to gain an electron. So really what's happening is the metal is going to transfer its electron. So this electron is going to come from the sodium and go to the chlorine. So write down the word transfer. Okay, that's going to be the key word we use for ionic bonds. So once this transfers, sodium then becomes sodium ion with a +1 charge. And now that chlorine has an additional electron coming from the sodium, it is now a Cl minus. Okay, so like we did before when we're making our compounds, we're trying to get these electrically neutral. So we put them together to get them NaCl. But really what an ionic bond is the attraction between these two positive and negative charged things. So that attraction is really what the ionic bond is, but you need the transfer first in order for that to take place. So ionic bonds are electrically neutral. Again, that was us making an ionic compound. And ionic bonds are always between a cation and an anion, something with a positive charge and something with a negative charge. And again, the key word I want you to write down is transfer, okay? So the transfer has to happen first. You make the two ions and then they are attracted. So I'm going to go through two examples so you could kind of see how we make this ionic bond. So I'm going to do calcium and sulfur. And I would suggest as you're watching this, you kind of pause the video and say, okay, what would I write down? And then see if you got the same thing. So the first thing I want you to write down is, again, what is the energy levels? So calcium is an energy level 4. So I'm going to write down energy level 4. Okay. And because it's in the second column, I am talking 2 valence electrons. So write down 2 valence electrons. And remember, this is a metal. So this is going to be the one that loses the electron. Sulfur is on the right-hand side, a non-metal. Okay. Do you notice that it's in the third energy level? So write down third energy level. It has 6 valence electrons. So write down 6 valence electrons. 6 valence electrons. So again, if we're doing the paper clips, okay, I have 6 valence electrons, but I want 8. Okay. And calcium has 2 valence electrons in its outermost ring. So what happens is these electrons move and get transferred. Okay, so draw an arrow and write the word transfer and be specific. I was not specific on my last example, but I want you to be specific on how many electrons are being transferred. So we're talking 2 valence electrons. So now calcium is a +2 charge. And sulfur has now gained 2 electrons. So now it's an S2 minus, an S2 minus. So we now have 2 things that have charges. They have opposite charges, so they attract. So this attraction is then what we call an ionic bond. So this gets to 0 by a 1-to-1. So calcium sulfide is what I want you to write down as your ionic bond. Okay. All right. So again, pause the video when I show you this next example and see if you could do the same thing. So now let's look at sodium and oxygen. Slightly different, but still the same. So see if you could pause the video and see if you could write down what are the valence electrons and all of that. So sodium is energy level 3. It has 1 valence electron. Energy level 2, it has 6 valence electrons. So again, this is my metal. It's going to transfer to my non-metal. Okay. So I am transferring an electron, but notice I am transferring 1 electron. I have 6 in oxygen. If I have 1 electron being transferred, I only have 7 valence electrons. That's not what I need. So I need 2 electrons to be transferred, okay? So that means I need 2 sodiums to transfer 1 electron apiece. It doesn't mean sodium starts to automatically lose 2 electrons. That's not what it does. Instead, you need 2 sodiums. Well, again, if both of these sodiums lose an electron, they become a +1. And oxygen, if it gains those 2 electrons, becomes -2. It doesn't want to just gain 1, it wants to gain 2. Again, where it's on the periodic table to get that magic 8. Well, before we talked to you about this and we started to do formulas, we would give you something with a +1 and something with a -1. And what did we tell you to do? You had to get it to 0. So it works this way to make the bond. You have to transfer 2 electrons in order for this to happen. If you don't transfer 2, it won't work. So that is why you need 2 sodium ions and 1 oxide to make this formula. So this is then Na2O is my final formula. Okay, so you're always trying to transfer the right number of electrons, or you could think of it backwards. Write the formula and go, oh, I must need 2 sodiums in order to get this to 0. So that's how we're going to make an ionic bond.